Does that look great? No. Right. The diagram shows two congruent triangles, BCD and BAE, where ABC is a straight line. In triangle BCD, BD equals 8, CD equals 11, and angle CBD is 65. There's loads of just words here, aren't there? The points E and D are joined by an arc of a circle, centre B and radius 8. Right. Find the angle BCD. Shh. It's talking in the live studio audience. So the angle BCD that we're after, what is that angle? BCD. 65 degrees. Hang on, what's going on here? Oh, good. Yeah, okay, I can't read. Right. Thanks. Thank you for sorting that out, Ben. It's very good that you speak candidly about what the question should say. Good work. Word of the week. Right, so BCD is that angle there. Oh, well done. Good. Phew. Right, how are we going to find that? Well, this is a classic sine rule question, isn't it? We've got an angle, the side opposite it, an angle, the side opposite it, so we want that angle there. So the sine rule says sine C over 8 is sine 65 over 11. So if we rearrange this, we get sine C is 8 sine 65 over 11. So we want to put that into our calculator and inverse sine, making sure the calculator is in which mode? Degrees, because we're working in degrees. So could I borrow the 991ES Plus? Thank you very much. Oh, look at the light flickering off the silver. Very stylish. 8 sine 65 over 11 is 0.659. But of course we need to make sure we use the full figure that's in the calculator to do inverse sine, shift and sine of that answer. And we get 41.2 degrees. We're going to give our answer to 3 significant figures because we're good like that. There we go, part 1 done. Apart from that, the slides still not working. Work out where the angle was. Show that angle EBD is 0.873 radians. So we've now switched to radians. Oh, by the way, it didn't specify here, did it, whether it was degrees or radians? So it was entirely up to us. If you'd given the answer in radians, then that would have been fine. If the answer in radians would be, just in case that's what you got, 0.720 to 3 significant figures. So if you got 0.720, that's just fine. Right, the angle EBD now we're interested in. EBD, this is this angle here. We want that angle correct to 3 significant figures in radians. Well, of course, this is a straight line, isn't it? So if that's a straight line, and this is these triangles are congruent, we're told that these are congruent, that means that that angle there is also 65, doesn't it? We can get that from the question. That angle there must be 65. In which case, all we have to do here is do 180 minus 2 lots of 65, and that will give us it in degrees. So that's 180 minus twice 65, which is 50 degrees. The question said, show that it's that in radians. So 50, remember if pi radians is 180 degrees, we want to know what fraction of 180 this is. So it's 50 180ths of pi, which gives us 5/18 of pi. 0.873 radians to 3 significant figures. There we go. Right. Hence, find the area of the shaded segment bound by the chord and the arc, giving your answer correct to 3 significant figures. Right. We know how to do this, don't we? The shaded figure, if we can find out the area of the sector, then that would be great. If we could then find out the area of the triangle that's inside it there, and we can subtract the first number from the second number, no, the other way around. First number, take away the second number, and we're left with that shaded bit. So that's what we're going to do. So area of the segment is going to be that's a half r squared theta, that's the area of the sector. And we're going to take away the area of the triangle. Run out of space, so like that. Area of the sector is a half times the radius squared, so 8 squared times the angle. And I'm going to use, as soon as Ben's FX991ES Plus gave me 5/18 of pi as being that value, I'm going to use that as my value there. Remember, we must be working in radians if we're using that formula. Take away a half r squared times sine of the angle. Now, I've used the angle in radians, so I need to make sure my calculator is now in radians mode in order to give me the right answer. Although I could have just written 50 in there and done it with it in degrees, and that would have given me the same answer. You can check that if you want to. Anyway, we get, what do we get? A half times 8 squared times 5 pi, oh, that's not the right button. Oh. 5 pi, good, I'm back on track, over 18. Take away, oh no, yeah, a half, sorry, just there, that times that, missed the times, don't know if it matters, 50 because I'm in degrees mode, close the brackets, haha, right, what did you get? 3.41 square centimetres. There is your answer to 3 significant figures. And brilliant. Loads of marks. What was that? 4, 5, 6, 7, 8 marks. Great. Any questions? Oh, there was a question too. How exciting. Yeah, go on, Lucy.
On that one I didn't write like sign, I just put like 0 point.
On this one?
And I've still got the right answer. I didn't put sign in.
You didn't do sine when you worked at the area of the triangle?
Oh, I did the triangle, but not the segment.
So you worked at the area of the
No, I
triangle?
mean sector. Like I just put in times 0.873.
Oh yeah, that's okay. So you did... Hang on, you did what?
Like I didn't...
You didn't take away the triangle?
Oh, is that... Oh, it doesn't matter then.
Are you okay?
Yeah, I'm sorry.
Did you do it in 2 separate calculations? Is that what's happened?
No, yeah. Yeah, it's fine.
Great. Question 2. We have another very, very similar question actually, with this difference between a segment and a sector of a circle. Express 140 degrees in radians. Now look, there's a difference here, isn't there? Giving your answer in an exact form as simply as possible. We're to convert from degrees to radians, we're going to write 140 out of 180 times by pi. That is the right answer, that is 140 degrees in radians. It did say as simply as possible, so that is 14/18 or 7/9 of pi, and that would be as simply as we can get it. Part 2. Find the, oh, this has actually changed, hasn't it? Find the perimeter of the segment shaded in the diagram This is funny. In fact, I think I remember doing this as a mock exam. This question is part of a mock exam with some students, and a load of them just kind of blindly blundered, another B word, straight into finding the area of this shaded bit instead of reading the question properly, and went straight into that. Because we're used to finding the area, aren't we? But this wants the perimeter, so that is going to be, what do we need? We need the arc length. That's the arc length plus the length of the line AB. That's the perimeter. Okay. Now, the arc length, I can think an hour to do that. What about the line AB? How are we going to find that? Cosine rule. Cosine rule, isn't it? Because we've got an angle and two sides adjacent to it, and we need the third side. So, let's work these bits out. The arc length is easy. The arc length is r theta, so that's 7 times 7 pi over 9, which would probably, well, we want to do it three significant figures eventually, but we'll leave it like that for now. And the line, well, this is cosine rule, isn't it? AB squared is a squared plus b squared, sorry. So, oh, well, yeah, it's that, I'm thinking of that being c squared is a squared plus b squared. Minus 2 times those two times the cosine at the angle between them, which depends what your calculator's in. Doesn't matter, does it? We're working radians. And this is going to give us a value, so 7 squared plus 7 squared, oh, hang on, minus 2 times 7 times 7 times the cosine of 7 pi over 9 gives me, AB squared is 173.07, so AB is the square root of that. So AB is 13.156 centimetres, and so the perimeter is 49 over 9 pi plus 13.156, which gives us, oh, I've just times, hang on, plus. Nice calculator to use, Ben. It gives me 30.3. Very good. I have to be a little bit careful of that because it actually gave me 30.259. Just there is a slight concern there that if you put rounded figures in here, there's a good chance you're going to go wrong at the end of it. So make sure you're using exact values as you're working out, because that's quite close to being 30.2, isn't it? And a rounding error along the way may just tip you over the edge. Okay, any questions? Great. And that's maths.